Hello, welcome back to our classroom. In this lesson, we are going to be talking about how to solve simultaneous equations using the elimination method. So you will learn about the elimination method and how to use it. You will also use substitution. And at the end, we're going to be talking about how to write worded problems in mathematical form. Let's talk about the elimination method. A simultaneous equation normally has two or more letters. For CXC purposes, your simultaneous equations will have two letters. Our aim in using the elimination method is to get rid of one of the letters. That is, to make it zero so that it's completely gone. This equation here has two letters or variables, x and y. By getting rid of the y, we will have the x. And by getting rid of the x, we will be left with the y. So we start by deciding which letter we want to eliminate. If we choose to eliminate the y, then we must look at the coefficients for the y. In this case, we see the numbers are 4 and 4. If we choose to eliminate the x, then the coefficients are 5 and 3. So, are the coefficients equal? Let us eliminate the y. So, we look at our coefficients, 4 and 4. The numbers are the same. So yes, we go to the next step. Are the signs of the terms the same? Well, no. One is plus and one is minus. So we have a plus 4y and a minus 4y, which means that our signs are not the same. And that is telling us to add the equations. So we are going to add the equations by simply drawing a line, putting a plus sign outside the bracket, and we're going to add the terms together. So we add our x terms together, which says 5x plus 3x, and we're going to add our y terms together, which is 4y plus negative 4y, and then we add our numbers together, 6 plus 10. Notice 4y plus negative 4y is 0, which means that this term, the y's, are completely eliminated. What we have left are the x terms. So we add both. 5x plus 3x gives us 8x, and the numbers 6 plus 10 gives us 16. We can now divide both sides by 8, and we get an answer of x equal 2. Now notice that a simultaneous equation has two letters, x and y, which means that you need to find answers for both letters. So we have our x value. Our x value is 2. Now we must find our y value. To find our y value, we can eliminate again, or we can substitute this value into one of these equations. I'm going to be using the equation 5x plus 4y equals 6. You can use any one of them. My x value is 2, so I'm going to substitute this 2 right here. So 5 times 2, which is what 5x means, 5 multiplied by x, plus 4y equals 6, which tells me 10 plus 4y equals 6. I can now regroup my equation to have 4y equals 6 take away 10. Then 4y is equal to negative 4, and dividing by 4, I get my y to be negative 1. So the two answers for the equation are x equal 2 and y equal negative 1. And those are the two solutions for the system. Let's try another example. Here we have 2x plus 3y equal 11 and 4x plus 2y equal 10. I'm going to be eliminating the y again. Looking at both, we see that the numbers are not the same. So, are the coefficients equal? The answer is no. To fix that problem, we're going to use this 2 here and multiply this equation. And we're going to use this 3 to multiply this equation. So let's multiply. 2 times 2 gives us 4x, 2 times 3 gives us 6y, and 2 times 11 gives us 22. Multiplying this equation by 3, 3 times 4 gives us 12x, 3 times 2 gives us 6y there, and 3 times 10 gives us 30. Our coefficients are now equal. So we look at the signs. Notice that both of these signs are the same. They are both positive, which means that we can subtract the equations. So let us subtract the equations by putting our minus sign and using brackets. So we have 4x, take away 12x. Here we have this 6y minus this 6y. And here we have 22, take away 30. Notice here that 6y take away 6y gives us a 0. So this one has been eliminated, which is what our aim was in eliminating the y. Subtracting the x's, we have 4x minus 12x, that gives us a minus 8x. And 22 take away 30 gives us a negative 8. We can now divide both sides by negative 8. And we see that x is equal to 1. Now that we know that x is 1, we can substitute this value into one of the equations. I'm going to be using the second equation this time. 4x plus 2y equal 10. My x value is 1, which means that 4 times 1 plus 2y gives me 10. So 4 plus 2y is 10, and therefore 2y is equal to 10. Take away 4, which means 2y is 6, and therefore y is equal to 6 divided by 2, which is 3. And our two answers are therefore x equal 1 and y equal 3. Let's look at one more example. Here we have the equation 3a minus 2b equal 12 and 2a plus b equal 1. So we can eliminate any letter. I'm going to eliminate the b. In eliminating the b, notice that one number is 2 and the coefficient of this term is 1. So they are not the same number, which means I'm going to multiply this equation by 1, which will leave it unchanged, and multiply this equation by 2. Now 1 times 3a is 3a, 1 times minus 2b is minus 2b, and 1 times 12 is 12. Here, 2 times 2a is 4a, 2 times b is 2b, and 2 times 1 is 2. Now my b's have the same number, and I now check the signs. One is plus, one is minus. Because they are different, we're going to add. So let's add. Now we have 3a plus 4a. We have negative 2b plus 2b, and we have 12 plus 2. So 3a plus 4a gives us 7a. This one is eliminated, equal to 14. And now we can use division to get the value of a. So dividing both sides by 7, a is equal to 2. Once we are here, we can either substitute or we can eliminate again. I'm going to do both. First, I'm going to substitute to find the value of the b. I have the value of the a. I'm going to use that value to find the value of the b using this equation. So 2a plus b equal to 1. My a value is 2, which means 2 times 2 plus b is equal to 1, which means 4 plus b equal 1, which means b is equal to 1 minus 4. So b is equal to negative 3. So my values are a equal 2 and b equal negative 3. If I wanted to eliminate again, Let me write the equations. Perhaps use a different color ink this time. So 3a minus 2b is equal to 12, and 2a plus b equal 1. Here we eliminated the b, now I'm going to eliminate the a. Getting rid of the b gives you the value of a, so now getting rid of the a should give you the value of b. Now look at the a's, one is 3 and one is 2. So we need to multiply. We're going to multiply this equation by 2, and we're going to multiply this equation by 3. So 2 times 3 here gives us a 6a, 2 times minus 2 there gives us a minus 4b, and 2 times 12 gives us 24. 3 times 2 gives us a 6a, 3 times b gives us a 3b, and 3 times 1 gives us a 3. Now we are going to look at the signs of our a. Here we have a plus 6a and a plus 6a, and because both are the same, we are going to subtract the equations. In eliminating our b, one was positive and one was negative. They were different, so we added. But the signs of the a are the same, so we're going to subtract these two equations now. 6a, take away 6a. Here we have a minus 4b minus 3b, and here we have 24, take away 3. So 6a take away 6a gives you 0. The a's have been eliminated. That leaves us with minus 4b minus 3b, that gives us minus 7b, and 24 take away 3, which gives us 21. So we're going to divide both sides by negative 7, which means b is going to be equal to 21 over negative 7 equal to negative 3. Notice that this is the same negative 3 we got here when we use substitution. So let me say it again. Having eliminated and gotten one letter, one value, you can either substitute that value into one of the equations, any of the equations, and do your workout and get your next letter. Or if you want, you can eliminate again to find the second letter. So our answers remain as a equal 2 and b equal negative 3. So you have two ways of finding your second letter once you know the first one. You can either eliminate again, or you can substitute into one of these equations. Now that you have become familiar with the method, you need to find some questions and practice with it to get better at it. The next part of this lesson, we're going to spend some time looking at how to write equations from worded statements. A huge part of the CSEC syllabus is devoted to comprehension. At one point in time, it was said that mathematicians did not need to be very good at English. Now CXC grades for comprehension, which includes a lot of reading and understanding. Now, we need to be able to look at this problem, translate it into mathematical form, and if necessary, solve it to get what we want. We're not going to be solving them here. We're just going to rewrite them, translate them, and write them into mathematical form. So at a shop, pens are sold for X dollars each, and rulers are sold for Y dollars each. Mr. James bought 4 pens and 5 rulers for $24. Mrs. Singh bought 2 of the same pens, that's important, and 7 of the same rulers for $21. So let's write the equations. For Mr. James, he bought, we're using X for rulers and Y for, what is it saying? Oh, X for pens and Y for rulers. So Mr. James buys 4 pens, that's 4x. He also buys 5 rulers, which is 5y, and his total cost is $24. Mrs. Singh bought 2 of the same pens, which means 2x, and she buys 7 rulers, 7y, and her cost is $21. These are the two simultaneous equations that result from this situation. Now the question could either go on to say solve them and find what the cost of each one is. In some cases, the question just asks you to write it. Here's another one. A restaurant bill of $350 was paid using $5 notes and $50 notes. The total number of notes was 16. So let X be the number of $5 notes and Y be the number of $50 notes. Now what do we know? We know that 16 notes were used. So the number of $5 notes plus the number of $50 notes will give us 16. And here we have one equation. Now the value of each $5 note times the number of $5 notes. Looking at the money this time, plus $50 times the number of $50 notes. When we add up both of those sums of monies, we will end up with $350. And that's your second equation. So you could now move on by solving this equation to find how much of each note was used. Let's look at some more examples where we translate. The cost of 4 chairs and a small table is $684. The cost of 6 chairs and a large table is $1,196. The cost of a large table is twice the cost of a small table. So we have, given that A is the cost in dollars of a chair, so chair, the chair cost is A, and B is the table cost. That is small table. But there's also a large table. And a large table has double the cost of a small table. The cost of a large table is twice the cost of a small table there. So let's write our first equation. The cost of 4 chairs and a large table. So we have 4 chairs and a large table. Let me restate that. The cost of 4 chairs, that's 4A, and a small table is 684. And that is one thing that tells us that whenever you're doing a worded question, as we looked at some time ago with Polia, you have to make sure that you read the question over and over. So sometimes one simple misread, and that will throw off the whole solution. So we have 4A plus B gives us 684. And then the cost of 6 chairs, that's 6A, and a large table is 1196. So plus large table, let's use a big B. But we're told that a large table is equal to 2 times the cost of a small table. So we can change this big letter B and replace it with 2B. So now we have 4A plus B equals 684, and we also have 6A plus 2B equal to 1196. These are the equations that we need to work with. Notice that we replace the big table with 2 small tables. All right, let's look at this one. 4 mangoes and 2 pears cost $24, while 2 mangoes and 3 pears cost $16. So this looks fairly straightforward. Write a pair of simultaneous equations in x and y to represent the information given above. So let us decide what to use. It says x and y didn't say which one to use for what. So we decide to use what we want to use. If we are going to write mangoes and peers. So we would have in this equation, the first part, 4 mangoes and 2 pears, which means 4x and 2y. That gives us $16. And the second one, that gives us $24. And the second one, 2 mangoes and 3 pears. That's 16. That would be the two equations that we need. So 4 mangoes, 2 pears cost 24, while 2 mangoes and 3 pears cost 16. That's part A. Part B says state clearly what the x and the y represent. So x here, as I wrote it before, does not mean mangoes, because what we want is what we are actually looking for. What we don't know, we already know how many mangoes. What we don't know is how much each one costs. So be very clear when you answer this kind of question. State clearly what x and y represent. X does not represent mangoes and y does not represent pears. X represents the cost of the mangoes and y represents the cost of the pear. So each mango will cost X dollars and each pear will cost Y dollars. All right. Here we look at 2 more examples. Denise sells 300 tickets for a concert. Some tickets are sold to adults for $5 and some for children for $4. So we have adult tickets and we have children tickets. If we say the cost of the adult ticket is $5 and the cost of the children's ticket is $4, then we can use some letters to represent them. Well, what do we know first up? We know that she sold 300 tickets. So if X represents the number of adult tickets, number of adult, that's what we don't know, and Y represents the number of children. Then the number of adult tickets plus the number of children tickets would give us 300, since 300 tickets were sold. What now for the cost? Each adult ticket costs $5 and each children's ticket costs $4. And when we add these monies, we would end up with 1,444. And there we would have our 2 equations that need solving. Finally, John and David have $14 together. If John's money is doubled and David's money is tripled, they will now have $34. So let X be John's money and Y be David's money. Of course, you didn't have to use X and Y. You could choose any letter that you want. So John and David have $14, which means that John's money that he has now plus David's money that he also has now is $14. The situation changes where if John's money is doubled, and that means to multiply by 2, which means that we're now going to have 2x. And David's money is tripled, which means that we're going to multiply by 3. And when you add those monies together, you'll now have $34. So this would be the pair of simultaneous equations that come out of this situation. In solving it, you could use the elimination method, and you could find the value that you want, and you could decide how much money that each boy has. But for now, our interest is in showing how to change these worded situations into mathematical form. Remember, in the elimination method, we're going to solve this one. We look at the coefficients. So I'm going to eliminate the x here. This equation is 2x plus 3y equal 34. This equation is x plus y equal 14. So I'm going to multiply this first equation by 2, and the second equation can remain as it is, or we can multiply it by 1 according to the tradition as it is. So this 2 and this 1. This will remain unchanged. So 2 times x gives us 2x, 2 times y gives us 2y, and 2 times 14 gives us 28. Now, this equation is unchanged because we're writing it as multiplying by 1, so we put our 2x plus 3y is equal to 34. We are eliminating the x term, so we look at them and realize that both are now 2 and both are positive. Because both have the same positive sign, we subtract the equations. So 2x, take away 2x, and we have on this side 2y, take away 3y, and we have on this side 28 minus 34. So 2x take away 2x, that has been eliminated. 2y take away 3y gives us a negative y, or negative 1y, and 28 take away 34 gives us negative 6. Y therefore is equal to 6 divided negative 6 divided by negative 1, which gives us a positive 6. So y represented David's money. So David had $6. Now, how much money did John have? We can substitute that number into this equation and find John's money. So John, using this equation, x plus y equal 14. We know the value of y. So x plus 6, since y is 6, is equal to 14. Therefore, x is equal to 14. Take away 6, x is equal to 8. So we are being told now that David's money is $6 and John's money is $8. Let's test it. John and David have $14 together. So if we add our 8 plus our 6, we get 14. If John's money is doubled, so we're going to double John's money. John's money is doubled, so he now has 2 times 8. And David's money is tripled, so he has 3 times 6. This gives us 16 plus 12 plus 18. 3 times 6 are 18. And adding those two monies, 8 plus 6 is 14. 1, 2, 3. We see that if that situation happens, if John's money is doubled and David's money is tripled, they have $34 together. So sometimes you might want to check your answers just to make sure that they work, especially when you're doing problem type questions. So this is how we solve simultaneous equations, by elimination. There are other methods to solve simultaneous equations, which we will get into in other lessons, such as in using matrices or in using the substitution method. You can also solve them using linear equations by drawing graphs. Thank you for watching this video. If you need more information like this and you're studying for CXE, please hit the subscribe button, and as soon as these lessons become available, you will be notified. Continue working hard at your exams, and all the best for your upcoming